Okay, this video is about the 5 different simple types of reactions in chemistry. I'm going to go through each type and give another example. But as you can see, we'll start off with a synthesis reaction. Some people think of this as the marriage reaction. 2 single people coming together to make a couple. So if we looked at a real chemistry example of this, it could be something as simple as magnesium plus oxygen. Oxygen gas is O2. And that's going to make Mg, which has a +2 charge. Oxygen with a -2, you don't have to cross anything. So the 2 does not go across. The charges +2, -2 cancel out. So that's why we write MgO. So now how do we balance this? Well, we've got 1 Mg, 1 Mg, 2 oxygens, 1 oxygen. So I got to slap a 2 here, and that means I have 2 magnesiums and 2 magnesiums. So that's a balanced chemical equation for a synthesis type of reaction. Let's look at decomposition. Again, this reaction some people think is a lot sadder. Think of a divorce. You got a couple breaking up into 2 single people. So here we are. Let's look at the reverse of the reaction above. This time you would start off with magnesium oxide, and you would break it up into magnesium plus oxygen gas. Again, we balance it by slapping the 2. We'll have to have a 2 here and a 2 here, and then it's balanced. So that's a decomposition reaction. The next type of reaction is something called a single displacement or single replacement. Some people put the word displacement, some people use replacement. Either way, you have one element knocking out the other. Now you have to figure out inside the elements whether it's going to knock out the positive element or the negative. The way you do that is you ask if this A is a metal. If this is a metal, it's going to knock out a metal. If this is a non-metal, it's going to knock out the second element, the C. So that's something you have to look on the periodic table for. It'll make more sense in my example here. So first, let's give an example of something very simple. Potassium is added to some salt. And of course, this would probably be in solution. And we would make potassium chloride, and some of the salt would come out of solution. It's a 1-to-1, 1, 1, 1, 1 solution. So it's a 1-to-1 balanced equation. Notice how the K knocked the Na out. So you got some single Na at the end. Let's try another one using the second element. So let's pretend we have some chlorine gas. And we're going to use sodium bromide. So here, which one will Cl knock out? It's a non-metal. It's not going to knock out the metal. It's going to knock out the non-metal. So here you're going to have sodium chloride plus bromine gas. And again, if you look on the periodic table, you'll see where it starts with nitrogen all the way down to iodide. That makes an L. Those are diatomic elements. That's why those 2's are there. Okay, that was a single replacement SR reaction, or some people again call it single displacement. Let's look at the next type of reaction called a double displacement. Here you have 2 different couples and they're switching. Yes, some people say this is kind of an obscene replacement, double replacement. They're switching partners. So let's go ahead and give you a chemical example, and then we'll give you one that really happened in my life. So we'll go ahead and start with something very simple like KCl, potassium chloride, and we're going to add some cesium fluoride to it. Okay, so we're going to make some KF, potassium fluoride,